Hello everyone, welcome to Knowledge on Sphere. Look at this beautiful picture. Do you know what this is? Yes, it's our home in space, the Milky Way galaxy. Just like we have a home on Earth, the Earth has a home in the sky. So the next time you look up at the night sky, remember you are looking at just a teeny part of our big beautiful galaxy. Now we are moved to a story, our blue pale dot.
February 14th, 1990. The Voyager 1 spacecraft is about 6 billion kilometers from Earth, beyond the planets of our solar system, screaming toward interstellar space. Following commands from NASA, the spacecraft turns and points its telescope at a distant object, looking back from where it has come. The resulting picture appears at first rather unassuming, but magnifying the image, we are able to discern a small blue dot. There, in that glint of reflected sunlight, is Earth, the place we all call home. This, dubbed by Carl Sagan, pale blue dot, gives us a perspective of our planet we humans have never seen. Suddenly, we are distant and fragile, obscure and isolated within the cosmos. How small, how seemingly insignificant, barely a dot. No detail, no continents, no boundaries, no definitions of us one from another. We are quite simply human. And to survive on this speck in our otherwise barren solar neighborhood, we will have to work together. Let's go back a little further to December 1968. The Apollo program has begun, and Earthlings are finally orbiting the moon. It fills their views in camera frames. And then, appearing above the horizon, there it is, Earth. Breathtaking. So this is what an Earthrise looks like. Move forward 4 years. The Apollo 17 astronauts leave humanity's last footprints on the moon. But before they even arrive, they too make photographic history. What a window seat. This is our first look at an entire disk of the planet. From 45,000 kilometers away, we see the deserts of Africa, storms over the Pacific, Antarctica in all its ice-covered grandeur. This picture becomes known as the Blue Marble. But wait, this is only one side of the planet. What of the Western Hemisphere or Greenland and the North Pole? This snapshot is an actual photograph taken by a human hand in space. It is only a single moment in time. Strikingly beautiful, yes. An efficient way to monitor and study our planet? Not really. But as you may have guessed, we're already working on that. In 1960, the U.S. launches TIROS-1, the first in a long line of spacecraft that will revolutionize the way we predict weather. The TIROS satellites continuously orbit the Earth and capture regional cloud images every 30 seconds, 24 hours a day. Stitching these images together, we create the first mosaic of the entire planet. As decades pass, these weather satellite missions evolve into a highly diverse Earth-observing fleet. By measuring various wavelengths of light, many outside the small fraction of the spectrum humans see with our eyes, we begin to see a bigger picture. 2002 brings a modern blue marble, this one of the entire planet. A true color, high-resolution mosaic made possible by combining the latest satellite imaging and processing technologies. This bird's-eye view of our planet allows much more than the prediction of next week's weather. We have now gathered decades of climate observations, time lapses, so to speak, of Earth's vital signs, Arctic sea ice cover, ocean temperature, greenhouse gases, and ultimately, global temperature. Scientists around the world are vigorously studying our planet, tracking changes over time, feeding models and simulations. As more and more data are gathered, identifiable patterns emerge. And what do we see? Sea ice and ice sheets are rapidly declining. The Earth is absorbing more heat. The oceans are warming, and in the process, climate patterns are shifting. This sphere that we humans call home is changing before our eyes. And we don't know exactly how this will affect our planet 50, 100, or 200 years from now. Ironically, the technology that allows us to see these trends was created by the very species that has the ability to affect, for better or worse, the future of this planet. Just why is the future of our pale blue dot so important? And why do we care? Consider the dramatic effects of climate change on the human family. Extended droughts, food and water shortages, increased extreme weather events. As sea levels rise, coastlines will be redrawn, and what will happen to the current cities and people who live there? Quite simply, climate change will affect all of us. Our species' ability to thrive, perhaps even survive, depends on humanity's stewardship of our pale blue dot. In the words of Carl Sagan, the Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit? Yes. Settle? Not yet. Like it or not, for the moment, the Earth is where we make our stand.
Wow, it's beautiful. Now we will move to another story, the story of El Nino.
What's going on? El Nino. The ocean and atmosphere are a coupled system, working to balance the Earth's heat distribution in response to the uneven heating of the Earth's surface. This attempt at balance drives the major wind patterns and ocean surface currents around the world as they dance to move heat to where it is cold and cool where it's too warm. The trade winds are the prevailing winds in the tropics, blowing from east to west, from the Americas to Asia, and in part a result of this unequal heating. These winds were used for centuries by sailing ships crossing the world's oceans to conduct trade, giving them their name. Normally the trade winds are strong, dragging warm water across the Pacific where it piles up in the western Pacific as a pool of warm water. When the ocean waters move away from the coast of South America, cooler, nutrient-rich water from below moves up to replace it, a process called upwelling. This nutrient-rich water promotes the growth of plankton, microscopic plants and animals that are prey for small fish that, in turn, are prey for larger fish. The result? One of the largest fisheries along the coast of South America. But in some years, the trade winds weaken, or even reverse direction, allowing warm water piled up in the western Pacific to slosh back across the tropical Pacific toward the coast of South America. The upwelling of colder water slows down or stops. This lid of warm, light water prevents the deep, cold, heavier, nutrient-rich water from reaching the surface. The result? The collapse of a huge fishery. This is what Peruvian fishermen call El Nino, the Christ child, because it typically comes around Christmas time. Even though the name El Nino has this local origin, its impacts can be global in extent. An El Nino usually occurs about every 3 to 7 years, and they aren't all the same. Some are much stronger than others. Really strong ones occur only infrequently, perhaps every 10 to 20 years. When a strong El Nino occurs, it can disrupt ocean conditions throughout the entire Pacific, which impacts weather around the globe for more than a year. The weather effects of each El Nino can be a blessing or a curse for different continents around the world. In some places, it may bring beneficial rain. In others, droughts, dangerous heat waves, and heavy rains and floods. Typically, an El Nino lasts less than 1 year. It ends when the trade winds regain their strength, pushing the warm water away from the coast of South America back to the west. But this adjustment may overshoot and swing too far, resulting in unusually cold water off the west coast of South America. This is called La Niña, the little girl. More often, it ends up somewhere in the middle. It's like a dance. Sometimes the music speeds up, sometimes it slows down. In this dance, the atmosphere initially has the lead and the ocean follows. Later, the ocean controls and the atmosphere follows. It is the extreme El Niños and La Niñas that take the greatest toll on humans and on marine life. Fortunately, our ability to forecast El Niños has improved dramatically over the past few decades. Our instruments have gotten better. Our records of ocean temperature have gotten longer. And measurements taken by satellites, used with those taken by ships and ocean buoys, are providing more detailed information over entire ocean basins. Our world is warming. Our climate is changing. How will this impact future El Niños? Scientists have made great strides in improving our understanding of El Nino, yet there is still much to learn, and many exciting research questions remain. As our understanding improves, our ability to predict El Nino and its impacts will provide tremendous benefits to people across the planet. This is just one of the important challenges we face.
Next, we will move to another show, the group of 8 of our solar system.
I am the sun. I'm a burning ball of fire. I'm very big indeed. Life on earth depends on me. I am the sun. I am Mercury. I'm the closest planet to the sun. I'm a ball of iron. I have no moon. I am Mercury. I am Venus. I'm the same size as the Earth, but I spin the other way, much more slowly. I have no water. I am Venus. I am the Earth, the place where we all live. There is land and lots of sea, so I look blue. I have a moon. I am the earth. I am Mars. I'm a rocky red planet. My mountains are the highest in our solar system. I have 2 moons. I am Mars. I am Jupiter. I'm a gas giant. I'm the biggest, and I spin the fastest. I have the biggest moon. I am Jupiter. I am Saturn. I'm a gas giant. My rings are made of ice. Titan is my biggest moon. I am Saturn. I am Uranus. I'm an icy gas giant. I'm the coldest planet in our solar system. And I have rings made of dust. I am Uranus. I am Neptune. I'm an icy gas giant. I'm the farthest planet from the sun. I have many storms. I am Neptune. We are the solar system. We are the solar system.
Do you know what is this? Yes, it's our moon. Very beautiful moon. With this show end here. Thank you everyone for being with us.